Good morning and welcome to Management Under Construction. I'm Brad Wyant.
And I'm Dee Davis. And today we are going to talk about managing the risk of Legionella or Legionnaire's disease through design, construction, operation, and maintenance. Brad, what have you heard about Legionella?
Not a whole lot. I only heard about it a little bit when I was working on a bigger project where we had cooling towers. If you don't do that right, it could kill people. I was like, what? They said it probably will be fine. And then I was like, okay, and moved on with the rest of my day. I didn't really register it as a risk and wasn't directly involved in implementing those cooling towers. So I didn't get a whole lot into it, but I'm excited to learn about it today.
It's something that isn't talked about very much in the industry, and it really should be talked about more because it's really a pretty interesting situation that we have in the industry. There's a lot of opportunities to get it wrong. We can manage it through how we design it, how we build it, how we operate it, and how we maintain these various systems. So, you know us, we're going to do a quick little history lesson before we dive into the topic. Legionella or Legionnaire's disease was discovered in 1976 after an outbreak in Philadelphia, Pennsylvania, at an American Legion convention. So, of course, it existed before 1976, but we didn't really know what it was before then. This bacteria, which is what it was present in the hotel's air conditioning system. The Legionella has pneumonia-like symptoms causing a bacterial infection of the lungs. Symptoms are typical flu, pneumonia type symptoms, cough, muscle aches, fever, headache, all those kinds of symptoms. It's treatable, but here's the thing. It's fatal about 10% of the time. So that's kind of a big deal. In the 1976 outbreak, 25 people died. And like most diseases, the people that are most vulnerable have compromised immune systems of some kind, respiratory systems or other kinds of comorbidities. There's about 8,000 cases per year, which is not a lot. But when you consider that 10% of those people are going to die, that's kind of a lot of people. I'm a member of the American Legion. I can tell you that most of the members are older, and that's probably why so many passed. A lot of them probably had other health issues that aggravated it. Outbreaks of Legionella are commonly in drinking water, fountains, hot tubs, evaporative condensers, and cooling tower systems. Legionella is naturally occurring bacteria that thrives in man-made water conditions that are not properly maintained. It's transmitted by airborne water droplets. So when water is aerated in any way, like when it's brought through a cooling tower, when it's brought through an aerated faucet, and in a drinking water situation, fountains, hot tubs, things like that, it's more easily transmitted to humans through the aerated droplets that we then inhale. And that's how we end up getting Legionella. And by the way, drinking water chlorination does not kill it. So that's not an answer.
Oh, not good. Okay.
Yeah. So we have to prevent it from growing in these man-made systems that we design and install. We have to prevent it from growing through design, construction, operations, and maintenance so that we don't have these kinds of problems in buildings. We had an outbreak recently. In July 2025, there was an outbreak in Harlem, New York. 90 people were diagnosed. 3 people died, or 3 people have died so far. This is August that we're recording this episode, so it's possible that more people could die from that outbreak. Interestingly, New York passed a law about 10 years ago requiring registration, inspection, cleaning, and disinfection, and testing of systems that can grow Legionella, and the outbreaks have only risen in New York. They're actually leading the nation right now in Legionella outbreaks.
Wow.
Studies show that there is a clear link between heavy rainfall and an increase in outbreaks. And before we started recording, Brad and I were talking about this episode, and you said it seems like there's more outbreaks back east than there are in the West. This could potentially be one of the reasons, is that it's linked to heavy rainfall. And this latest Harlem outbreak occurred about 10 days after a heavy rainstorm, which is the incubation time for Legionella, not surprisingly.
So how did the rainfall connect to the infection? Is the rain impacting people when it falls on the street and it's just misty out? Or is there something going on between the building system in the rain?
Well, there's certain types of fixtures where it might be more predominant. So, like if you have a cooling tower, that water is recirculating back. It's an open system. And so it's open to the atmosphere. You get rainfall in, and you're constantly introducing new things into the system. If you're getting rainfall in and you're recirculating that back into your building system, the same thing can happen with an evaporative condenser. And it can happen with open fixtures like fountains that are recirculating water in. You're getting the rainfall in there. It's naturally occurring bacteria, don't forget. So you're getting all these environmental things. It could also have to do with temperatures during rainfall events. There's certain temperatures that Legionella really likes, and rainfall events kind of fall into that category. We'll talk more specifically about the temperatures that Legionella likes to grow.
So Legionella is a bacteria that causes Legionnaire's disease. It's related to respiratory issues, and the bacteria grows under certain conditions that we can prevent or cause with good or bad design in our buildings. Does that about sum it up?
Yes, correct.
All right. So let's talk about design. What can we do to prevent this bacteria from growing in our building systems?
Well, we need to avoid dead legs. So a dead leg in a piping system is as a leg or a section of pipe that has water in it, it's wetted, but doesn't get circulated. So that's what we call a dead leg in design. So if it's not circulating or seeing regular flow of water, it's considered a dead leg. We need to avoid those because all kinds of little buggy bugs can grow in dead legs of pipe, and it doesn't matter what kind of system it is. It's a bad thing to have a run of pipe that doesn't see circulation. We want to avoid designing systems that run in the Legionella hot zone, which is 77 to 113 degrees, or for those of you who operate in Celsius, that's 25 to 45 C. One thing that I've noticed in building designs recently is the introduction of tepid water systems. This is a really interesting challenge that we have presented ourselves here. We're trying to solve one problem and we're sort of creating another one. In design, I've had 3 or 4 different design reviews that I've done in the last couple of years where tepid water systems have come up. The reason we're starting to see these is there was a code change a number of years ago that says we're required to provide tepid water, and the ANSI definition of tepid is 600, the ANSI definition of to 60 degrees to 100 degrees Fahrenheit for eye washes and safety showers, instead of just whatever comes out of the cold water line. These are emergency devices that are found in laboratories and anywhere where there's chemicals in buildings. Imagine you're working in a lab or you're working somewhere there's chemicals, you get splashed with chemicals, you need to rinse those off of you. We go to an eye wash or a safety shower for that. Well, imagine you go over there and it's ice cold water. That's not fun, especially in the wintertime. Splashing all over you, you're probably not going to adequately rinse that off. What we've done traditionally in these eye wash and safety showers, we've provided warm water at the point of use by running hot water line and a cold water line and using a mixing valve right at the eye wash or the safety shower. And we mix it right there so that it comes out warmish, tepid, right? That's a little bit more comfortable for the person that is having to do that. Have you ever had to use an eye wash or a safety shower, Brad?
No, thankfully. I have seen them, I've put them in, and I have always thought, boy, that would stink to be in a situation where you have to use that. There's a lot of dangerous chemicals in the plants that I've built, and you just don't want to ever be in an instance where you're risking your eye safety. Wear your safety glasses, everybody. Wear your goggles, wear whatever PPE you have to wear, because having to use an eye wash station is a bad day.
It's a very bad day. I've had to have my eye flushed before. It wasn't a chemical. I got something in my eye and the safety person had to come and forcibly flush my eye. That was not pleasant, I can tell you. And it was not tepid water. It was room temperature water, which is a little bit colder than you really want it to be for that. But you have to flush for a long time to get something out of your eye. It's not fun. So you don't want to be slamming people with cold water or hot water when they have to use these. So in an effort to minimize cost, which is something that we're always trying to minimize cost in construction, somebody said, hey, why don't we put a tepid water loop instead, and we'll just have it feed the eye washes and the safety showers. And then that way we don't have to run separate services to all these and buy mixing valves that then need to be maintained and replaced. Sounded like a great idea. And so the tepid water loop is born. Here's the problem. Tepid water runs between 75 and 90 degrees, which is the sweet spot for Legionella. We want it to be comfortably warm without it being scalding, but lots of bacteria besides Legionella grows in that temperature range. And these fixtures, again, are not used except in the event of an emergency. They are the absolute definition of a dead leg.
And as far as building maintenance goes, there are probably a million things further up on somebody's priority list if they're running a plant that has a safety shower and an eye wash station to try to keep people safe, to try to make the building profitable above this kind of a thing. One of those things that gathers dust in everybody's building, or at least they hope it does, that it only is needed if you really, really need it, which is very infrequently. But when you need it, you really do need it. So expecting somebody to do something like flush that dead leg once a week would probably be a pretty egregious requirement. It would be an undue, odorous burden for somebody to take on.
When I started seeing these tepid water loops come into designs a couple of years ago, I already know what building maintenance does on a regular basis. When you're working with labs, hospitals, places like that, they do flush certain fixtures on a regular basis. It's not weekly, though. It's monthly. Is typically, and when you've got just hot and cold water and a mixing valve, monthly is all that's required because your dead leg isn't sitting at the temperature that grows this kind of stuff. So your dead leg is sitting at room temperature.
Like you said, the incubation is 10 days. So 10 days, you're flushing maybe once a week, and that's a lot of flushing.
Exactly. So that was the first question that I had when I saw this start popping up in designs. I said, whoa, whoa, whoa. Have you talked to facilities maintenance about this? And they're like, what do you mean? At this temperature that you're circulating, you would have to flush these fixtures weekly. And they said, oh, well, don't they already do that? And I said, no, I'm going to guess that they flush monthly, but ask them. And they went and asked, and facilities maintenance said, well, we're not doing that weekly. There's no way we can. Are you kidding? It would be a full-time job. Somebody would, and this is a larger facility that had a lot of eye washes and safety showers. And they said, we'd have to hire somebody to just go around and flush fixtures all day, every day in order to do it weekly. Flushing isn't just turning it on for a second. In facilities where you have all these chemicals and solvents and stuff, you're not allowed to put floor drains underneath these showers and these eye washes. So you have to run a 55-gallon trash can on wheels underneath the safety shower, and you have to let it run for several minutes to really flush the water out. So it's a very manual process.
Okay, let's divert for a moment because I'm interested in what you just said. You can't have a floor drain under an emergency shower?
In a lot of facilities, you can't because of the chemicals. Because if you think about it, if you put the floor drain there, the floor drain then has to tie in. Where's it going to go? You've got chemicals that you're washing off. Now it's a chemical drain. You don't know which chemicals are going to be there. You don't know the volume of chemicals that are going to be there. It can't go into the sewer.
You'd have to plumb it to some waste line that may not even exist in the building systems.
Hard to say. So in most jurisdictions, you are not allowed to put a drain under a safety shower. It depends on what they're doing in that space. I've seen it in some spaces, but in most spaces, we get told no.
And that's so interesting because it's like, okay, well, you can't drain it to the sewer, but you can splash it all over the floor of your controlled facility where everyone else is going to try to be working, where it might be so acidic that it chews through people's shoes. That's a great idea. Yeah, totally.
Well, that's what PPE is for.
Right.
And training, and there's proper cleanup procedures in a facility like that.
It goes to some waste stream eventually. It's just interesting. I'll give my final thoughts at the end. I don't want to spoil it, but there's certainly a lot of best intentions gone awry is a theme I'm seeing in these regulations and these ideas here.
Well, a conventional sewage system is not equipped to deal with acid waste and base waste and things like that. The piping that is on a typical drain is not intended to deal with that. the system that it goes through is not intended to deal with that or reduce that. Usually in these kinds of facilities, any cleanup that you would have to do from a spill like that gets put in a very specific container and is hauled away by a trained third-party company that then properly disposes of it. Now, what is that proper disposal? That's beyond my area of expertise. I know who to call. And these companies are on contract with these facilities and come and remove liquids from the lab all the time that are, wasted liquids that they've used in tests or whatever, liquids and solids, and they take them and properly dispose with them. And I don't know exactly what that means. I don't know where they go.
But we have a guy, person.
There's a guy. Call the guy. Yeah, absolutely.
All right. So we've kind of covered design. We don't want to have dead legs. And if we do, we need to design into the system and let buildings operations know that they're going to have to flush this thing. But the risk of Legionnaires in these 75 to 90 degree zones is much higher. And having dead legs, which is what these showers and eye washes end up being, is a very dangerous thing, even though it's per quote unquote code.
Correct. That particular code is dealing with one thing. And that one thing is the water going to be too hot or too cold for the person flushing? That's the only thing it's addressing. It's not addressing Legionella or any other thing. It's not addressing building maintenance. It has one thing in mind. Sometimes when we're trying to solve one problem, we create a different problem. And we have to pay attention. And I would caution any designer who's considering a tepid water loop not to just willy-nilly make that decision without talking to facilities maintenance, because we as designers do not get to dictate to facilities maintenance, hey, we're going to design a system that's going to cause you to have to do way more maintenance on a way more frequent schedule. We don't get to make that decision. That's an owner decision. We need to advise and say, look, hey, if we do this, these are the consequences. The owner gets to decide we're either going to do that or we're not going to do that. Right. So far, all the owners that this has come up with have declined the tepid water loop except for one. I had one owner that accepted it, and we added a UV system to it. And, I can only hope that that's going to be enough. We recirculated the water and UV.
So at least it's not still, and you're adding something that bombards the water with ultraviolet rays in the attempt to kill any bacteria?
Yeah, but you still have dead legs. I'm not confident that in the long run, this is going to be the right answer. Because you're still going to have dead legs that, yes, they've been UV treated, but then once the water gets into the dead leg and it sits, then what? I wasn't thrilled about the outcome. I would have preferred to get rid of the tepid water loop, but this owner did not choose that route. So there we go. We'll find out.
Well, so tell us about operations. We talked about design. This UV system seems like a very interesting and challenging thing to implement, kind of fun. What can the operations people do to prevent Legionnaires within their buildings?
There's a number of things. The CDC recommends that building water systems run at temperatures higher than 124 F and lower than 68 F to avoid waterborne diseases. So when I think about that, I can think of a whole lot of buildings that I have been a part of that run their domestic hot water at 120 or 118 because they're so terrified of scalding somebody, which in reality, I don't know. I've always thought that 120 is a bit on the low side. Well, according to the CDC, it needs to be at least 124. So that's something to consider. When we run piping systems in the temperature range for the purpose of human contact, as in the case of sinks, eye washes, and safety showers, it's considered the same category as drinking water and must be treated as such. It's considered domestic water. And I guess that's, again, where my concern comes in when we're running something that's considered hot water, but we're running it at a temperature below 124, we could still be growing something. With any fixture, you're going to have some kind of dead leg. So be aware of that. As a facilities maintenance person, when you're looking at the operations of your facility, think about the sinks and faucets and fixtures in your facility that maybe don't get used very much. If it's not used, it's a different kind of dead leg. It's a dead leg by default. If you have a remote sink or shower in a room that doesn't get used very often, that's a dead leg. I've been in facilities where in the changing rooms, there's showers. Well, do those things really get used? In some
Mhm.
facilities, they do, and in some facilities, they don't ever get used. Well, that's a dead leg. Now, when somebody does go to use it, guess what's coming out?
So they're going to want to have to shower off of themselves.
Yeah, it could be a drinking fountain, a shower, a faucet, anything like that. It is a default dead leg if it's not used. So in operations, you have to really think about that kind of stuff. In addition to your eye washes and your safety showers, what else in the facility doesn't get used a couple times a week at least? And even in a couple times a week, if it's got a metered faucet on it, it gets used once a week and it's a boop boop. They just turn on and off by a sensor faucet. There's not enough flow there to flush anything out. They're automatically turning on and off very quickly. Those need to run for several minutes in order to flush out what's in that dead leg.
Wow. Huh. Well, the engineer in me wants to solve this problem by designing a better solution, by designing showers that automatically turn themselves on at 1 a.m. once a week for 4 minutes and with faucets that run themselves every so often. But that's sort of a fantasy. We don't have that kind of technology yet. We don't have that. And it would be so costly if we did choose to go that route that it would beggar belief. We'd be selling platinum building systems to people that can't afford them, and we'd be raising the cost of construction artificially. But this is a very scary thing. The idea that the systems we build could be hurting people if they don't get implemented correctly, if they don't get flushed often enough. There's a lot of risks here. So do you think that there's enough awareness around this risk, or do you think that this is the kind of thing that gets reported on and then we forget about it and go on with our daily lives? I mean, I know the way I feel about the water. I don't think about the water coming out of my tap until I move to a new building and then test with my little zero water filter and see how bad it is. And then I usually use my water filter, even if it's not too bad. It's one of those things that we isn't always at the front of our minds because it's so accepted as part of our lives.
Yeah, I think it is not in the forefront of our mind enough as building professionals, which is why I wanted to bring it up in the podcast. It's something that, especially in healthcare facilities, is mostly where people are finding Legionella.
Wow, really?
Yeah, well, you got to think about it. I don't know if you've ever built a hospital before. The last hospital that I built was about a 500,000 square feet, 10 stories plus a couple of basement level service areas, thousands and thousands of plumbing fixtures, faucets, eye washes, safety showers. Every single patient room is private, and there's hundreds and hundreds and hundreds of patient rooms. And every patient room has 2 sinks and a shower.
Mm.
They have one for the staff when you first come into the room. You have one in the bathroom, and you have a shower in the bathroom. So you have 3 fixtures in every single patient room, almost without fail. There's individual patient rooms. There's certain kinds of patient rooms where you maybe wouldn't have a shower or you wouldn't have a restroom. But then you have the nurses' stations, and then you have the break areas. There are countless fixtures. So to think about how the different spaces are used, I've been back into that hospital recently in the last year, and some of the spaces that were designed as family waiting areas are no longer being used as family waiting areas. There's sinks in those rooms for people to wash their hands, and now they are not being used. They're vacant 99% of the time. Are those faucets being flushed on a regular basis? I don't know.
Wow. And I'll bet a part of that too is that the people who end up in hospitals, like the people at the American Legion, are usually a little bit older, a little bit more susceptible to disease. The hospital bug that people talk about when you go to the hospital, there's just so much in the air, no matter how good the ventilation and circulation is. It's just more sick people around each other are going to get each other sick. And I can just imagine healthcare workers being told, yeah, you got to do this other thing where you just go around and flush sinks, and nurses just being like, no, I have no time for that. It's such a high demand environment that expecting additional burdens to be accepted to the community of people that work on those buildings, it's probably a thing that falls to the bottom of the priority list, like in other buildings.
Well, in that particular facility, I know the facility manager, and he's very diligent and very good about most things. But when you have a case like that particular room that I'm talking about, it was designed and built for one use, and it's being used in a completely different way now. And that's probably happening on multiple floors and multiple areas. I mean, that's just the nature of what happens when we build buildings. We build them in these spaces with a certain thing in mind, but that's not always how it's utilized. So is anybody thinking about that room with that sink and that fixture? And is it on the list of being flushed on a regular basis? I don't know. I hope so. But things like that don't seem like a big deal or easy to fall off the list can create these kinds of problems for us.
Well put.
So in the case of eye washes and safety showers, since they are only used once in a while, those we have a tendency to keep more in the forefront of our mind because we know that they are very rarely, hopefully never used. Here's the good news. I found this out in one of the buildings that the tepid water loop was proposed in was a building out in California. And so I looked into the regulations for what is considered tepid water according to code. What is that temperature and what is the building inlet water temperature? Do I even need a tepid water loop in a mild environment like Southern California? According to ANSI standard Z358.1, if your incoming water temperature to your building is in the range of 60 to 100 degrees F, you're good. You don't need to do anything else. We were actually able to delete a tepid water loop in this design and do nothing and just run cold water to those emergency fixtures without doing anything. No hot water, no tepid water, no nothing, because we meet the standard.
So that ocean views and the best Mexican food in America is what you pay those higher California state income taxes is for, huh?
No mixing at all. That's good for people who are environments that can take advantage of that standard.
Mm-hmm.
Okay. Cooling towers is the other major offender. For anybody listening who doesn't really know what a cooling tower is, sometimes when you're driving along, you see behind a building and there's this big vapor cloud that's coming up, especially in the morning when you have a temperature differential. That's more than likely a cooling tower. And what a cooling tower is the open side of a cooling system. So you have a chiller on one side and you have the condenser water on the other side. The condenser water goes outside, drops to the top of the cooling tower and comes down, gets mixed with some more water. You have tons of evaporation, which is why you see those billowing clouds coming out of those things on a regular basis. What they're doing is they're ejecting heat in that process. Heat is leaving. Also, it's kind of misty around there. You're getting a lot of water droplets, which is where Legionella loves to be transmitted. So we have to pay very close attention in cooling tower loops to make sure that we are putting proper treatment in that water. We can't just run raw water without it being treated. There's inhibitors that are designed to keep that water from scaling those cooling towers and building up all kinds of limescale, and it also keeps bacteria in check. I have seen cooling towers, oh my goodness, growing moss on the side. That is an indication, really bad scaling, moss growing, practically looking like barnacles on the side of a ship. That is a bad system that is not being maintained, and that can create illness. It's a very good idea to have a third-party water treatment company be responsible for proper maintenance of your cooling towers. They do routine chemical treatment. They have chemical feed systems that are constantly feeding so that you don't have to manually do it. And then they come out once a month at least and check levels and tweak things if they need to and make sure everything keeps in check. The flip side of that is you have to keep your chemical treatment people in check. There should be somebody on your staff that knows something about chemical treatment and is checking on those guys pretty frequently. I have had great experiences with chemical treatment people. I've also had the flyby chemical treatment people that come by your facility, they're there for 5 minutes and they're gone. Well, guess what? They're not actually doing anything.
And in this particular circumstance, not doing much of anything is really unacceptable. Doesn't sound good.
And your systems will reflect it. Proper maintenance of your cooling towers and your condenser water system will prolong the life of your equipment. Cooling towers are not cheap. It is not something you want to be replacing every 5 to 10 years. You should be getting 20 years out of those things. And I have had phone calls from clients that say, hey, I replaced these cooling towers 5 years ago, 7 years ago. and I'm having problems with them.
Mm.
99.9% of the time, improper chemical treatment.
I can't imagine that. That would be such a bummer to spend that much money knowing that you were very penny wise and pound foolish effectively there. If you're not paying the right chemical treatment company, if they're shorting you on their service and that's causing you to have to buy a whole new cooling system every 5 to 7 years, the math on that gets aggressively bad.
Well, and you'll see it in your cooling towers first, but you can also foul your chillers this way too. I mean, cooling tower replacement could cost you hundreds of thousands of dollars, depending on how many cooling towers you have and how big they are. Your chillers are going to be even more expensive. You have to properly maintain those. If you're having to perform maintenance on your chillers more often than you should, then that's telling you a story too, because the scaling will happen inside the chiller as well. And your water treatment is incredibly important in an open system like that. It's even more important, I would say, than in a closed system, a closed cooling or closed heating system, although those are also very important. You can be eating pipe and boilers and things like that too. Okay.
Open water systems do not sleep on the.
No, they do not. You're constantly losing water, so you're constantly adding fresh water, which requires even more chemical treatment. So domestic water systems, those are the ones that probably scare me more than anything. Design out as many dead legs as possible. If you have a hot water storage tank in your facility, make sure you're storing your hot water at least 140 degrees F. Distribution should be 124 or higher. I know there's tons of facilities maintenance people listening right now going, no way, I'm terrified of the liability of scalding somebody. But you also got to remember that you lose a lot of temperature in your distribution. Insulate all your hot water piping to maintain your temperatures. Cold water systems ideally run at 68F or less. Take precautions with faucets that are used infrequently or in combination with low flow or automatic faucets in infrequent use. Review facilities maintenance program closely, including the flushing of domestic water systems in infrequently used sinks, showers. Don't forget places like gyms, standalone showers, or rarely occupied or used spaces. Design water storage tanks that have recirculating pumps. Still water is a bad thing. I think everybody in this industry knows that. Moving water is better. So make sure you've got recirculating temps, not only to help maintain temperature, but to keep that water moving. You can install sample ports for regular sampling and testing to make sure that you're not growing anything funky in there. And weekly flushing programs are recommended by the CDC. And again, I know most facilities only do monthly flushing programs, but weekly is recommended. You can use microbial filters of 0.2 microns or less. If you have a specific fixture or maybe a group of fixtures that you know is hardly ever going to be used, you can use a microbial filter at that location, a point of use filter. But again, somebody's going to have to go replace it periodically. And it only manages the point of use. It doesn't manage the loop. It just manages a specific fixture for you.
Boy, I mean, it's just whack-a-mole with problems like this, isn't it? This is the way with all design. When you solve one problem, you cause another, and you have to counter for that. There's no such thing as a perfect system that absolutely, totally, perfectly mitigates all the risks. There will always be things that have to be done, effort that has to be put in to ensure that systems are operated and designed safely. And there's no one size fits all, perfect target, silver bullet solution. But you can certainly help yourself out by studying these kinds of topics, understanding the science behind the systems we install, and advising your clients, whether they be the facilities operations people or the owners, on what is the best solution for them in their particular circumstances.
Yeah, budget often plays a role in the design decisions that we make early on. And that's really how the tepid water loop came into existence, is it was a budget cutting consideration. Instead of running hot water and cold water and having mixing valves, oh, we'll just run a tepid water loop. It seems like a great solution on the surface. And from a design side, it's beautiful. From a maintenance side, not so much. And every designer that I've come back and talked to, when I see these on the design and I call up the designer and I say, hey, how did we get to this place? They've never even considered the maintenance ramifications for it. It's just not even something that cross their mind.
And because, as we talked about before, they're thinking about their realm, they're looking at their software, they're understanding the building from their perspective. They're not being forced to consider the life cycle costs of the building because they don't have an adequate way of estimating the life cycle costs of the building from all stakeholders' point of view in their software.
It's the whole picture. And that's the challenge that we always have in the industry, is taking into consideration the entire picture. And we often don't, within one company or within one group, we don't always have the expertise. I'm going to guess that most designers have never been a building maintenance person. And vice versa. Most building maintenance people have never been designers. So they don't understand enough about each other's worlds to think about the ramifications and to be able to adequately do that. It's why it's even more important to bring facilities maintenance people into the design conversation as early as possible. We have to consider all the aspects of design decisions, including upfront, long-term cost savings and implications, and make sure we consider all the aspects when we're tempted to jump into a money-saving solution. I can recount many, many instances in my career where somebody jumped onto what appeared to be a money-saving solution early on in a project, only to find that it actually cost them more money in the long run.
You get what you pay for, no matter what.
Exactly. Thanks for joining us. We'll see you next time. Watch us on YouTube at YellowstoneProfessionalEd.co. Don't forget to like, share, and follow us, Apple, Spotify, everywhere you listen to your podcasts. You can email us with questions, comments, and suggestions at heydee@managementunderconstruction.com. That's HEYDEE to get me or Brad at managementunderconstruction.com.